So we actually were hands-on. We build developer tools, POCs. So, in a case where a group like ESPN or Parks and Resorts has a need for something, a tech service, we'll help them to build that, or we'll build it for them, and we'll build it in such a way that we can share it with the other groups. And we try and eat our own dog food and all this stuff. So, I just recently did a service to support ESPN and a bunch of other sites that is running in Docker with GKE. That was a total experiment, and I'm the first person in this group to have done this, just so that we could say, here's how it can be done,
right,
and the hurdles that we had to go through to make it work, and and then use that and share it with everybody
So
else.
I'm dying to know how that went. How did the experiment go?
That's I have a really long, hour-long talk where I go through the adventures and perils of GKE and Kubernetes that I'm giving on Thursday in Disney, but it's all private. But I can talk a bit about some of the issues. It was a mixed bag. I have a kind of a love-hate relationship now with Kubernetes because.
Did you go in with a hate-hate relationship or a love-love relationship?
No, I was very enthusiastic. I expected. Okay. I had very high expectations.
Oh, it's the backpacking trip where everyone starts
exactly.
off filled with enthusiasm, wearing flip-flops.
You get those. This is going to be great.
This is going to be awesome. Got the sun shining. What can go wrong on Mount Rainier?
Somebody brought Neospore, I hope. And actually the beginning part. So to set the stage. This application that I was converting to GKE, luckily it's a very simple app, Node.js, single API endpoint, microservice. Actually, I compared it and did a building cost analysis for using Lambda as a potential target for it, which fell through for other reasons, mostly the auto-scale billing of Lambda, which I can go,
that was up and to the right.
That was
right, okay.
That way.
Yeah, right, that way.
The more TPS you hit, that really adds up. And this was a high throughput service,
okay.
So that was a main reason for it. But luckily,
so Node.js, microservice, stateless. So this should be sweet spot.
And fault tolerant. So it basically just included CDN assets, some JavaScript code, talks to an API. It has retry logic. It can handle the service going down. We ran it outside of Kubernetes, just on static nodes for 6 months. For 6 months,
right?
Basically forever,
right?
And it had full uptime, and it was great. When it moved to GKE about 2 months ago, I have spent more nights and weekends debugging production outages than I have in the last 15 years on any service.
Wow!
It was. It was wild, and a lot of that, admittedly, was my fault because I jumped into Kubernetes. Having gone through Kelsey Hightowers.
No. Yeah, wait a minute. Now I think you're blaming yourself too quickly. But okay, so because your fault. How is it your fault?
Well, okay. So I had high expectations that Kubernetes, that the API and the documentation would be very clear, and that the tooling would just do what I expect.
You're right. It is your fault. Those are ridiculous expectations. How dare you expect that?
I really needed to lower the bar.
Absolutely. God, it disgusts me that you would expect such a thing.
So it's not just the Kubernetes API. So G-Cloud, just Sunday, they had an issue with the autoscaler, and the Google support representative said, well, you should turn off the autoscaler because our autoscaler might try and fix your machines again.
Did they put it in air quotes? Do they have I'm making air quotes over the phone?
I think he literally, this was over a ticket online, and I think it actually had quotes on it.
It's going to fix your app, like we fix a dog.
Yeah. And so I said, well, all right, let me try that. I guess I can babysit this today. This was on Sunday.
Right. Yeah, I got nothing to do.
And then this was Sunday.
I don't have a family. I don't have kids.
How many sports games happened on Sundays?
Right. Exactly.
On that Sunday.
Right.
That was actually our highest traffic for the service over the last year. But luckily, because the documentation was so bad and because there was a bug in the system, I could not disable autoscale because the function for doing it was just broken. But the function for doing it was not what I originally expected, because in order to create the autoscaler on the cluster, you put -- enable --autoscale. So I thought, well, that should be -- disable --autoscale.
God, once again, you disgust me with your irrational expectations.
And
it's obviously -- enable --autoscale equals false.
Well, no, really, it's -- no -- enable --autoscale. Because it's like, why?
Yeah, of course. Obviously, because we don't have a word in English for no enable.
No.
We haven't come up with it. God, someone should come up with a word for no enable.
So that threw me for a loop.
And if you want to enable it, it should be no enable. It should be not no enable.
Yeah,
That's how we'll enable it. That's like,
Disenable.
okay. All right. I'm having like rage by
Unenable.
proxy here. This is like, okay, but this was a positive because you couldn't disable it?
It was because it turned out to be our highest traffic day.
Right, okay.
And
Thank God for the lack of documentation.
Yeah, the auto-fail cluster management actually managed to scale pretty well, even though many of the pods were restarting and it had a lot of issues. It still took the traffic, and because of the fault tolerance in the system that I'd built in, it was fine, and it was great. And I saw the graph, I was like, woo, hey, yay, good. Even though they said it was not going to work, it sort of did.
So, okay, I guess that's a positive.
I know.
That sounds great.
I was in like cold sweat.
It's like, good news, I ignored your advice because the documentation was wrong, and the thing that you said was broken worked by accident.
Did you?
So, mission accomplished.
You read my support comment.
Exactly, that's right. I think I must have gotten into the ticket system. Yeah, wow, that's great. Well, that's been a great Sunday. That was fun. Yeah, but it does. And so it shows that these things are still in development.
There's still a lot of the good features that are in GKE are still in beta.
Right.
That's another, mea culpa, jumping in
right.
into beta.
I'm sorry. I assumed that the software was actually. When you said production ready, I assumed you were production ready.
And so the HTTP load balancer, right, which is what's fronting the entirety of this application, on Friday went down for 2.5 hours across all of GCP.
Okay.
So that was a service outage.
Yeah, right.
Well, I got a service alert and I was like, what's going on? And I looked, and sure enough, when I went to Google support to file a ticket, it said in big letters, our HTTP/HTTPS load balancer is experiencing an outage. We don't know why. We're looking into it.
Okay. Thanks. Well, asked and answered.
It's out.
Okay. Well, I guess I'll go back to sleep. That's good to know. It's all broken. Thank you.
Yeah, that was the one time where I was like, well, I can't just futz with Kubernetes and try and get this to work myself. Most of the time, I was doing most of the support work myself, which was highly educated. I managed to get a Google support engineer.
You're such an optimist. I'm amazed.
So I managed to get a support engineer on Google Hangouts for 6 hours, in which we both learned all about Kubernetes, because
it's a journey. We're on a journey.
Many times the support engineers would tell me, we're very new to this. GKE and Kubernetes is.
Did you mean to say that to me? I'm your customer.
Totally new. So we're going to investigate, and most of the time I had to tell them why it failed after going through many debugging experience of my own. But it's a process. So even to this day, even after all of that, I feel like I mean the Dockerization part was painless and awesome. Like Dockerization is the way to go. We're Dockerizing everything. That's just a no-brainer. And then I still have high hopes for Kubernetes because even with some of the API issues and the things that are in development, it is moving, right? There's a lot of development on it, and so mixed bag.
Yeah, I mean, I feel like, is this like a 13-year-old stealing cars though, where you're just like, yeah, he's got so much promise, like, yeah, but he's stealing cars.
Yeah. But he's smart.
He's smart. He's got It's like, well, he's not in jail. But I guess you did see the promise of the auto scaling. It sounded like the auto scaling actually, ultimately, if by accident, worked and absorbed the load.
Yeah. So when the load balancer died on, or when the load balancer. Yes, the HTTP load balancer. When that died, the ingress on Friday, I actually witnessed the autoscale working.
Right.
It was traffic started to bleed down as it died, and the pods drained down and the machines drained down, and then as soon as it came back up, it started picking up and building up nodes again. And
so that's promising. But honestly, how many of these things are? How much of it is Kubernetes? How much of it is immaturity? How much of it is GKE? It's obviously a combination of all three of these things.
Yeah, that is a really good question.
All three are involved.
It's all three. They're all three new.
All three new, right.
And it's a growing area.
Right. Well, but you could say, and I guess it's valuable to do these early serious, because you're doing a serious enough experiment. Because it's a little bit frustrating when people are deploying new technologies, but not in production. And they're like, oh, it's great. It's like, but no, you're not actually, like, you're not having the Sunday meltdown.
Exactly.
You actually, somebody needs to deploy this thing in production.
Yes.
And on behalf of humanity, let me thank you for being willing to be the one into the breach.
Luckily, I had this great opportunity with this app because it could handle the downtime.
Okay, so another question I got to ask you. So Kubernetes is very frameworky in that things kind of happen magically. And which is like, this is a contrast to some other things. So, I mean, I think the older I get, I'm concerned that in software there are two different camps. You've got kind of the framework folks and the library folks. You know what I mean? Where like in the frameworks, it is the master control program, the framework that has control, calling out into your logic as it sees fit. Very quick to get something working, but you have these issues where it magically fails.
So,
I mean, first of all,
I would almost contrast that backwards because it was, even after Kelsey Hightower's Intro to Kubernetes talk, when I felt like I had a great understanding of Kubernetes, it still took me 4 days to Kubernetify my app. It was a lot of going through documentation and finding a lot of,
inconsistency,
errata, old documentation, changes to standards, people recommending one way and then it actually should be done a different way.
Right.
And once I actually got all of the YAML files set up and I had the script to create and destroy the cluster and I could like dynamically recreate this whole thing and destroy it, then it was like, well, now I can actually tweak the system and make these micro changes and it's kind of nice, except it's very slow to the uptake because Kubernetes is constantly trying to fix the system. And so I would change the horizontal pod autoscaler and the request CPU on the pods, and it took a few minutes to recognize those changes and to actually put those into effect. And sometimes, a scaling event would happen and then I would go to fix something and my fixing it would actually make it worse.
Right. It's like the thermostat problem where it sounds like you're adjusting the thermostat at the wrong time, not waiting for the house to heat up or cool down. So that's a challenge though, right? I mean, is that I guess this is the downside of magic, is that when magic, when it magically works, it's great, but when it magically fails, it's really perilous.
Yes, and actually digging into logs was really challenging too, trying to figure out why certain things have failed. I had a problem just today actually with spinning up synthetic monitoring on this service, and for some reason I couldn't get the liveness probe to work, the health check for it.
Right.
And I tweaked a bunch of different things. Eventually, by removing
doesn't it drive you crazy though when you're doing that kind of stuff?
Yeah.
When you're like, don't you feel like a monkey?
And then
don't you feel like an actual chimp?
Totally. But the fact that nowhere in it a log says, hey, this is broken because there's a conflict or this thing was named wrong or whatever. Just like, no, connection denied. Can't do a health check.
And you're making like these random changes to config files, and you're Googling around, which I hate. I mean, I feel like B.F. Skinner is somewhere watching me, just like, and until he goes to the food pellet, it's like, I feel like, I don't feel like a high order great ape. I feel like I'm using my animal brain. I'm in like constant fight or flight. I hate it. And I mean, I so hate having to Google stack traces and stuff like that. And the worst thing, by the way, if you really wanted to create havoc with humanity, just go to a bunch of bad suggestions to fix problems and follow up with saying, thanks, that worked for me. I had the same problem and fixed it. Because I mean, if you're like this antisocial, I mean, if you're the kind of person that likes, likes to, I mean, you will really screw some people up because it'll be like, it worked for this dude. It worked for no handle icky cop 428, and why doesn't it work for me? It's
you and I should team up. I'll make the bad suggestion. You say it worked.
Oh yeah, exactly. Oh, that is such a devious idea. That is so.
We could take down the world.
You take it down. Yeah. We are going to burn this place down. You're not going to be able to Google a stack trace ever. I mean, everyone is going to have to actually figure it out. I'm sorry. You are no longer. But I mean, I hate being reduced to that stuff. You know?
It's terrible.
It is terrible. And I don't know. I have these moments where it's like, is it me? Like, should I just be more accepting of this? Do I have like an anger issue? Okay, probably. But I mean, or should we? I mean, is there something more fundamentally amiss? And I guess with Kubernetes, I feel my jury is honestly out. Like, I honestly don't know. because you remember like Heroku had these issues too. Like, do you remember the Rap Genius Heroku thing? Remember this? Folks, so Heroku had this issue where Rap Genius, are they still in business by the way? I guess they are.
Yeah.
I don't know. Are they a unicorn? Whatever.
They're
I don't
around.
Even know. Yeah, they are. Are they doing self-driving cars?
Is anybody here from Heroku?
Yeah. But Heroku had an issue where the monitoring software did not properly indicate that it was actually the Heroku control plane that was the issue. And it felt like it was one of these things that felt like it was a natural consequence of the level of framework that you get from a PaaS.
Yeah.
I don't know. But
well, I mean, I think that's probably very similar to what happened with the cluster autoscaler. I mean, their master that was managing the cluster autoscale, something was wrong with it. And I didn't have any insight into it because it was not even just a framework, but a framework that I had outsourced to this vendor. As opposed to, there was other groups in our organization who were playing with running the Kubernetes master, doing the whole thing.
And so would that be kind of a middle of the road position? Like, okay, maybe this is new enough that paying someone else to run it is maybe we need to, if we're going to run the magical framework, we should run the magical framework ourselves, so I can at least hop onto a box and figure out what's going on?
It depends. I mean, there's an argument for having that vendor support and kind of do the legwork of fixing those bugs for you, right?
Right. You say
to
this
some degree.
Just after your,
maybe.
You know what I feel like my good friend and longtime colleague Adam Leventhal wrote a blog entry on his first Rust program. And it was just like, I mean, it looked like he was trying to do like facial reconstruction surgery with a nail gun.
Sure.
I mean, it was just like, oh my God, this is like, looks like the most awful experience. He's getting these error messages, you're like, and he's like, this is inscrutable and that's inscrutable. And you get to the end of his blog entry, you're like, oh my God, Adam, thank you. You have suffered, so I don't have to. And literally the last line of the blog entry was, in conclusion, wasn't that bad, might do it again. And like, what sort of Stockholm syndrome is this? Like, you've been so abused
it's
that this makes sense.
yeah.
Like, you've been, like, Rust is gaslighting you, dude. I mean, are you?
I still feel like it's my fault.
Do you need help? Yeah, exactly. Like, I feel like there should be like a Kubernetes crisis line you can call that just like, no, but I mean, do you? I
think it's a wait and see. I mean, like, my recommendation. I mean, it's on Thursday. I'm giving this to the Disney crowd. Is, you know, I would not do this exact experiment with many of our other services, right? I mean, this is something that I would only have done with this one service that could handle this kind of failure, that, you know, where I could respond quickly enough to it, and the CI/CD deployment to Kubernetes is fantastic. Like a build, test, deploy in 2 minutes, done. I deploy like 15 times a day.
I too love CI/CD, but I feel that CI/CD is a misleading workload because it is so easy.
Oh, it's totally easy.
It doesn't matter if it's down. It doesn't matter if it doesn't matter if it takes a long time. It doesn't matter if you restart. You don't have the auto scale phenomenon. I mean, it's good if you can't do CI/CD, you can't do anything else. So that's good.
Sure.
But I do feel we kind of lower. Yes.
It just reminded me of another issue that I had, which
Please
was,
go on. This is obviously valuable for you. So this is very important that we.
This blows my mind.
Okay.
And maybe I'm just crazy, but. Kubernetes, the default when you create a deployment and you do deployment, I was doing deployments and then going, why am I having downtime when I do a deployment? What's going on? I was running a lean cluster of 3 nodes with 3 pods, which is 3 Docker containers, right? And it was doing rolling update, right? The default in rolling update in Kubernetes is max unavailable 1. That means that when I do a deployment, it destroys a machine, which throws the workload to the other two pods that are there, which I'm trying to run them as high capacity as I can, which means now they're overloaded, and now an autoscale event triggers while it's doing a deployment. and
not funny, but it's funny.
Yeah, and it was what, and or in some cases it was like max out the nodes, they're denying connections. The health checks are now failing because they're getting full of connections. And now they're dead because health check is failing. And so max unavailable 0. Easy solution, easy default. But that's not the default.
That's not the default. Well, but that kind of, I think, I do feel that we kind of lull ourselves into a sense of security, like, I've got 3 of these things. They can't all fail at once. It's like, well, unfortunately, the system behind them is complicated, and I feel that our outages now are going to look a lot like a lot more like power outages. I mean, this is like the Great Northeast Blackout of 1965, right? Where
I remember that.
Right, exactly, right, back in the day. No, but no, or actually, you may remember there was another blackout that's actually a West Coast blackout that I don't know, you probably also still too young to remember, but the 1996 or 1997 on the Pacific Intertie, hit a tree. Yeah, okay, good. So you remember this. So a tree grew into the Pacific Intertie, and 1/5 of the power generation capacity on the West Coast was gone. And but the other lines cannot take the overload, and you begin to get these cascading failures.
Exactly.
And I don't know if you know anything about 3 Mile Island. 3 Mile Island, I am convinced, is like the metaphor for software failure, where you have this big cascading failure. You've got very complicated systems that you're trying to engineer kind of on the fly, and the idea that like you've got your auto scaling and your upgrade operating at total cross purposes.
Yeah.
That feels like a ghost from the future. You feel like an apparition sent back to the present from the future. Are you the ghost of Kubernetes future?
That is a hard question. It's probably somewhere deep within my psyche at this point. Yeah.
So, I mean, but you're doing an incredible service, honestly, for not just for humanity, but for your own organization in terms of being an early adopter on this stuff.
That's really what my team is all about, is trying to set the stage for the next step and help people make the right decisions. You know, we're trying to make it easy to do the right thing, whatever that happens to be next. And so we have to evaluate and take those chances.
Right. Well, and pays off. I mean, even on like a mixed experiment, you see some of the value in there. You can kind of try to find the right things.
Yeah, and at the very least, I've captured a lot of errata, right? I mean, that's like I'm going to deliver a list of pain points and things to watch out for and things not to do, and defaults to override.
Right. Well, and do you think is that getting fed back into Kubernetes?
It is. So I've opened several tickets now with GKE. I mean, there's silly things too that at least I thought would have been basic, like how many so Kubernetes or GCP has a graph of your CPU consumption over time.
Okay.
Or your throughput over time. It doesn't have a graph anywhere, any visualization or collection of how many pods was I running? How many machines did I have up?
Oh, don't worry about that. That's fine.
No.
No, that's called your bill. Don't worry. You'll see it in the bill.
Yeah,
You'll see it in the bill. That's fine.
It's in the bill. It's just a
You're
number.
running plenty.
And you can use the API and you can query and build that graph yourself. And I'm like, I'm busy trying to fight this production outage. Why? I can't. Yeah.
Right.
So anyway, that was one that was like, guys, build this. This is easy, simple stuff that you should have in your dashboard. And then, several other of the tools that I was using along the chain ended up finding issues with and filed. I mean, this is the thing, is that we're on the edge, and that means we're filing a lot of tickets.
Right.
And we're trying to make it better for the next person who comes along.
A lot of GitHub issues. I mean, I don't understand. In some of these projects, I mean, Kubernetes, I think, is over 20,000 GitHub issues. I think. I mean, it's like, how does anyone keep track of that?
I don't know that they are.
Okay, that's right. I guess that's the answer. I guess the answer is simpler than I thought it was. Yeah, I mean, but it's really, I think this is one of the challenges when you've got something that is being adopted so quickly in so many different ways. It is very hard. I mean, and we saw this problem with Docker too, where you have and you'd have this GitHub issue that is having this intensive design discussion on it. And then all of a sudden that issue's closed out, and we're on to like 5 other issues because someone has decided that, like, we're not going to discuss this over here, we're going to discuss it over there.
Right.
And I'm glad that we're in this all open source world, but this is challenging. I mean, this is something that, I mean, coming the proprietary software world. I mean, we know we can't go back to that world, but that world did give us like releases that worked, right?
I don't know that I can agree with that entirely.
Sure. No, I mean, by worked I mean frequently broken, but I mean that they were. But I mean, I think that we have now accelerated ourselves so much. I mean, now the latency between ideation and production is getting cut shorter and shorter and shorter and shorter, and it means it's up to the early adopters are the ones that end up actually finding a lot of this stuff.
Yeah, and it means that our applications more and more need to be fault tolerant.
Right.
So.
But wasn't your application? Did you do that? Aren't you blaming yourself again?
It did survive.
Okay, good. All right, okay, that's true. I guess it wasn't deleted.
It was actually great.
Kubernetes did not delete your app.
I would see the traffic die, right? The cluster die, and then as soon as it got back stable, I would get all this traffic, and I would be like, "Look, it came back.
Right.
I'm okay.
We're alive.
Yeah,
right.
we're great."
Yeah, there is, and I do feel that and I think many of the people in the room deal with production systems, support production systems. One of the things that's very important to me as a software engineer is I think it is very important that the software that I develop, I'm also supporting in production.
Yes.
Because production is, I mean, people, you know, the Dollar Con in this last year, they're talking about how great production is. It's like anyone talking about how awesome production is doesn't actually have any production apps. Production is war, and war is hell. I mean, production is actually terrifying.
It is a babysitting job.
It's a babysitting job with like felons. You're babysitting felons. I mean, because you have, and like, there's that moment, and if you've got if you deal with any production app at all, you've had that moment where it's like, it's not going to come back. Like, it's gone forever, it's not going to come back. I need to move to a different city and find a different line of work, and then you have that moment like you're doing the upgrade and things have gone so far sideways. You're like, please God, just let me get back to the state of the system before I started screwing with it. Like, I promise I'll never touch it again. And everyone's like, oh, like, you should continuously deploy. It's like, okay, okay, maybe, but that means, and I guess that ultimately does have to be the right answer. But it means.
There were several times in the beginning of the Kubernetes problems when I was having problems with my cluster where I just said, well, screw it, I've got shell scripts for create and delete.
Right.
and I literally just said, delete the whole thing, recreate it. It took 4 minutes, right? I mean, like, as opposed to having hours of downtime where I'm investigating what the hell is going on, I just said, screw it.
I am actually rebooting the internet.
Yeah.
Right.
Reboot. Get that Netgear router out.
Right.
Yeah.
But and that's ultimately, that can't be an acceptable solution going forward. But I guess it does. It did prove some of the promise in terms of being able to stand this stuff up quickly.
Yeah, exactly. And so there were ways that I could have said, all right, I'm going to stand up multiple clusters, multiple node pools.
Right.
And so I can experiment. I could suffer outages there. I could fail over.
Right.
I mean, like, I could have certainly done this in ways where I would have had zero downtime, even with GKE outages.
Okay, so but that brings up that does bring up the economics issue at some point,
yes.
right? I mean, the idea of like, oh, just spin up another one, spin up 2, spin up 5 more than you need. It's like, hey, Google, you keep giving like,
this was a common support. Yeah, so I would reach the support and I would say, hey, the autoscaler isn't working. This is going on, and they would say, well, just make the cluster size bigger and see if it goes away. That was their answer several times. It's like, well, add more resources, see if it goes away, and I was like, no, it's causing an outage right now. Like, I'm not going to see if it goes away. Tell me why it's happening.
Right. I mean, what line of business gets away with this? Like, oh, I'm sorry, is your experience dissatisfactory to you? Like, maybe you should buy 5 times as much. Right. It's like, what are you talking about? It's like, instead of buying the burger, buy the lobster.
And they kept telling me I wanted to run these nodes at peak capacity. Right. I'm trying to use all the system to be economical.
Right.
And they're like, no, put the auto scale threshold at 60%. And I'm like, well, once I get a lot of nodes, that's going to be a lot of wasted CPU. Like, why? Really?
Oh, I wouldn't call it wasted. No, exactly. I would call it a bank error in our favor.
Definitely going to pay for it.
Autoscaler error in our favor. And so, I do feel that like and this is what I wonder about containers in general. If we're not going to see a kind of Jevons paradox. Jevons was a Scottish economist who observed in the mid 19th century that as coal use became more efficient, coal use went up, which was surprising. And coal use went up because, of course, now it became more economically viable to use in more kinds of things.
Sure.
I do wonder if we're not going to see that with compute.
Yeah, just more compute.
Yeah, it becomes easier to use more compute. And I mean, obviously, we need the economics of that need to square out. But so a big question I've got is, are we using more compute to do the same amount of work than we used to?
I definitely think so, because this is one of the things that I hit when I was trying to go through this auto-scaling stuff. I was like, well, I started with the 1 vCPU instances, which is the default with Google clusters. And then I ended up having to go to 2 vCPU because I realized that actually with Kubernetes, with the GKE logging and the daemon set pod that they gave me in order to fix low connection max settings, for some reason they throttled these machines down and gave them limits to the connection pools, and that caused some problems.
Well, so with 1 vCPU, you're clearly indicating that, like, I care about nothing. I don't care about my computer.
So the 1 vCPU,
I don't value myself.
Those instances were already 30% reserved just by running Kubernetes.
Wow.
And so I could only allocate 70% to my app. And so I had to go to 2 CPUs so that I could actually run my app effectively. But that's the thing, it was like, just throw more compute at it was the answer.
Right.
And the whole time I was like, wait, now I'm running 6 CPUs to handle the same traffic that I was running with 3 CPUs on static infrastructure. I didn't have autoscale, but I also didn't have to autoscale because I'm only taking, it was like 1,000 TPS at max, this service has done so far. But for some reason, I had to get that autoscale motion and to handle that in GKE.
This is how you know that we're getting old. Like we're ready to be like, in my day, you could run, But you do wonder that if we are being less efficient I can see both sides of this. I mean, I can see that it's great that we're able to stand this up so quickly. But maybe it is
I think you hit on something really, really crucial, which was that framework and sort of I don't know what's going on outside the system or around it or in that instance and the default configuration with the connection settings and everything. Whereas it's a highly tuned Node app that I was building here. We've got very quick execution times. I did everything I could to tune this thing. So it's not laziness.
Right.
But there were situations where I was like, what is going on? Why is this machine actually filling up on CPU? And it's because the CPU is being used by the logging system and by all this other Kubernetes stuff that's like churning through and using the input-output, and it's doing a lot of things that I didn't have to do before. And so that was one of the big lessons, was by adding Kubernetes, I'm really adding a lot of extra need for compute.
Interesting. Is it a conspiracy? I mean, this is a genius.
Maybe.
If so,
It could
this
be.
is genius. We are. I mean, Larry and Sergey are. They've actually bought this thing. The whole hog. So we don't have too much time left, but I did want to get to talk about some of the serverless stuff you're doing.
Oh, sure.
And I did throw up in my mouth when I said serverless. I just want to make that absolutely clear. That it's like that your serverless stuff is actually running on a server. I can assure you.
Yeah. Serverless. You mean no ops, right?
Right. Exactly. Oh God. Oh
Yeah.
Jesus. We give demerits at Joyent for trolling.
No, it's terrible. So I evaluated serverless for this service, and it kind of bugged me because as I was looking at the pricing guide in Lambda, which is the only serverless option that actually has a pricing model that's public right now, because everybody else is beta and preview, and everybody's doing serverless because it's really easy. It's basically just Dockerized functions that you trigger and STD out to whatever you want.
Right.
So,
bam, you're hashtag serverless.
Yeah, being done.
You can be serverless in a tweet.
Yeah, exactly. It's pretty simple, except for managing the autoscale and the load balancers.
Right.
Which, I don't want to rebuild all that stuff.
Production. Yeah.
So that's great. But anyway, so in their pricing model, they're like, yeah, look, if you have a service and it takes 3 million hits a month, then it'll cost $16 a month. And I was like, that's like one hit every second.
Okay, this is
what is that?
Changing the denominator on operations. This should be a crime.
That's not an API.
You should not be able to quote. Operations should be quoted in one time unit, and that's seconds.
Yes.
You with me?
Absolutely.
This whole
So I had to convert
how many
all this.
operations per week does this thing do? How many ops per fortnight is that? It's like, no, we don't. No, don't.
And it's hilarious because it starts out and it's like you get 1 million free hits and 400,000 free gigabyte seconds of compute time.
Right.
And I'm like, okay, that's so. Now, don't get me wrong.
Do they actually say 1 million free hits? By the way, they sound like the world's largest LSD
Yeah.
dealer.
Oh, totally. Yeah.
Okay.
All right. First hits are free, man.
Yeah, I guess so. First million hits are free.
Yeah. And that's actually really great because if you have a service that's just like a workflow, like I do a build job and it hits Lambda, and I'm not going to use 1 million hits a month, then hey, you get free service. That's actually pretty cool.
Right.
But if you're trying to run an API, like you can't just then say, I'm going to take ESPN.com and break it apart and turn it into serverless, because it's going to cost you like $500 million a month to run that, because a million hits a month is like 1 hit every 3 seconds.
Right.
That's nothing.
That is nothing. That's actually nothing.
That is
actually
nothing.
my son's rate of hitting reload on Instagram.
Right.
I mean, that is actually. I think, and I highlight, that we are actually at the point. I do think that it's interesting because this is a conversation that we would not even have had in Vegas, because we are further along.
Yeah.
Right. It is a sign that things are getting real.
Definitely.
And now we actually are going into production with this stuff.
Yep.
But it means the bar's going way, way up. And now billing matters, economics matter, the pricing matters, and reliability matters, resiliency matters, upgrade matters. A lot of this stuff now matters.
Billing is hugely complex too. That was one of the takeaways I had from this is I did a cost estimate for all these things, and then I looked at the bill and I was like, wait, I had 5 line items and there's 30 line items, and some of these I didn't see in the pricing guide anywhere.
You do feel that some of this pricing is so complicated. I swear the Glacier pricing is so complicated that I feel that it might be actually like mutually self-contradictory, and Amazon just uses it as an excuse to make up whatever number they want if you ever have to restore from it. I mean, it's like you look at the Glacier pricing and it's like off the charts complicated. Like, or maybe you need to spin up a Hadoop cluster to figure out your Glacier bill, and they figure out like that's like, no, we actually have a service that you can run to calculate your Glacier bill. It's in Lambda. That, by the way, did you see the auto scaling? I was like, wait, I'm in some like massive Ponzi scheme.
Yeah,
I don't know what's going on. Anyway.
Yeah, so when I did the comparison for this particular service, I was estimating, current, this is POC numbers of like 80 TPS and then 300 TPS and then 50,000 TPS, because we're actually looking at doing a lot more with this service. And by the time we got to the 50,000 TPS, it was like, well, it's like $18,000 to run it in Google, about the same in Amazon, and it's like $70,000 in Lambda. To do the same thing, just because if you are actually going to max out the CPU and utilize all that, it makes a lot of sense just to reserve the instances.
Or buy hardware. I don't want to say. I don't want to say something that's too radical. But a 2U server actually does a ridiculous amount of work. I mean, I don't want to. I don't want to like slow everyone's roll. Totally. Or anything. I don't mean to go like all like steampunk on everybody. So but you could actually buy like a 2U server with like half a terabyte of DRAM for not that much money.
No, you weren't at the Node Summit in San Francisco, right?
Yes.
So I heard so many people, so many groups saying, hey, we went all in on AWS, and now we're trying to pull out because the micro billing for everything is, I mean, it's, everything's cheap, but our traffic is going up, and we have no idea how to control this growth of
And you
billing.
can't control your own economics. Your unit economics are fundamentally wrong. And, I mean, it's been kind of like summer in VC land, so it's all kind of, but winter is coming, children. Winter is coming, and when winter comes, cost matters.
Yes.
And I think that it's a challenge. Utility billing favors the utility. That's who likes utility billing. And we need to get control of our costs somehow. Well, Adam, thank you very much. I feel like we talk all night, but thank you very much. I really appreciate it. This has been great.